This short podcast will cover Raoult's law, a way to calculate how vapor pressure can be lowered when you make a solution. Of course, we now know there are many colligative properties, and those again are properties which only depend upon the number of solute particles present, not on the identity of those solid particles. The colligative properties that we've learned so far have included boiling point elevation, freezing point depression, it says melting point depression, but I call it freezing point, osmotic pressure, but the one we haven't really spoken of in any detail is vapor pressure lowering. As you can see in the diagram on the left, there's a pure solvent signified by the blue spheres, and it shows that it's at equilibrium. If the container top is sealed, particles leave the solution and go out into the vapor phase and also return and eventually reach an equilibrium vapor pressure as long as the temperature isn't changed and we don't do anything to contaminate the solvent. But in the picture on the right, if you add a solute, that's pictured by the red spheres, now you've increased the intermolecular forces of attraction between solute and solvent, and two things happen. You see fewer vapor molecules that are in equilibrium above the solution, and you can see that the green arrows leaving and entering that solution are smaller, indicating that the rate at which they do so is decreased since we've increased the intermolecular forces of attraction of the solute for the solvent. So the vapor pressure of a solution is lower than that of its pure solvent, and it can be quantified by using this thing called Raoult's law. You will need to know the mole fraction of a compound A, that would be symbolized with the letter X. You're going to need to know what is the normal vapor pressure of your substance, and if you do, you will be able to, through simple multiplication, calculate the vapor pressure of the solution. So it's important to know that you have the vapor pressure of the solvent, and in this particular calculation of vapor pressure lowering, our solvent is going to be water. So we take a non-volatile, non-electrolyte like glycerin. Remember, we don't want to introduce the Van Hoff factor to do battle with the Raoult's law. So if we take glycerin and we know its density and have a temperature, we should be able to, if we have a volume of that glycerin, be able to calculate its moles. And sure enough, they've given me 50 milliliters of glycerin, and they put it in 500 milliliters of water. Both are liquids, so we're going to say the water is the solvent. So now we want to see what would be the vapor pressure of water if you add a solute of glycerin to it, and we would need to refer to a water vapor pressure chart to know that its water vapor pressure at 25 degrees Celsius is 23.8 torr. So according to the Raoult's law, we're going to need to get the mole fraction. So I'm going to first of all calculate the moles of my glycerin. I take its volume times the fact that it has a density of 1.26 grams per milliliter. Now I will have grams. Last step, divided by its molar mass, and we have the moles of glycerin. Water is quite simple. 500 milliliters of water is equal to 500 grams of water because its density is 1, and I will divide by 18 to get the moles of water. So remember, the mole fraction that we're talking about is the moles of the water, not of the glycerin. So what we want to know is the vapor pressure of the water. So it will be moles of water divided by the total moles of water plus the moles of glycerin, and that value is 0.976. Remember, mole fractions are always decimal fractions. And now all I have to do is leave that number in my calculator, multiply it by the given value of the water vapor pressure at 25 if it's pure water, and now I can see that the vapor pressure has been lowered slightly to 23.2 torr. So relative to pure water, it's 0.6 torr smaller according to this sample exercise. That's pretty much all there is to the Raoult's law. Use this as a guideline for the 3 or 4 problems you have about vapor pressure lowering, which you will find either in your practice problems worksheet or in the colligative properties worksheet. Until then.